Every drop of sunflower oil begins here, not in a factory but in open fields powered by sunlight. Sunflowers are grown not just for their beauty, but because their seeds are biological oil reservoirs designed by nature to store energy for future growth. Sunflowers exhibit heliotropism, tracking the sun to maximize photosynthesis. More sunlight means more energy stored in the seed, and more energy means a higher oil yield later during extraction. The real value lies inside these seeds. Each one contains lipids, natural fats, stored by the plant as chemical energy. Industrial oil production exists to efficiently unlock and preserve these lipids at massive scale. Timing the harvest is critical. Seeds must reach optimal moisture and oil concentration. Harvest too early, oil content is low. Too late, seeds degrade. Precision agriculture ensures consistency before industrial processing even begins. This is the first mechanical separation. Plant material is removed while seeds are collected intact. Protecting seed structure matters. Damaged seeds oxidize faster, reducing oil quality later. At this stage, the goal is preservation, not extraction. The factory needs seeds that are uniform, dry, and biologically stable because everything downstream depends on starting purity. Only after biology, agriculture, and logistics align do the seeds begin their journey to the factory. What happens next is no longer farming, it's industrial transformation. When sunflower seeds arrive at the factory, they are still a raw agricultural product. Before oil can be extracted, the seeds must be standardized, cleaned, separated, and physically prepared for precise industrial processing. This receiving pit is the factory's first control point. Every batch is logged, weighed, and sampled. Oil yield, moisture content, and contamination levels are measured before processing even begins. Cleaning isn't cosmetic, it's chemical protection. Dirt, stones, or plant debris can damage machinery and introduce unwanted compounds that degrade oil flavor and stability. Magnets silently remove metal fragments. Even microscopic steel particles could spark fires or contaminate oil during high pressure extraction. This step protects both product and plant. Sunflower shells contain fiber but no oil. Removing them increases extraction efficiency and prevents excessive waxes and pigments from entering the oil. Airflow is used instead of force. Hulls are lighter than kernels, so controlled air separation ensures clean kernels without crushing the oil rich core. Conditioning gently warms the kernels. Heat softens cell walls and reduces oil viscosity, making extraction more efficient while avoiding thermal damage to nutrients. Only now are the seeds ready. Clean, dehulled, and conditioned, engineered for one purpose, releasing their oil under controlled industrial force. This is where mechanical energy replaces biology. Mechanical presses convert rotational force into extreme pressure, enough to rupture oil bearing cells and force liquid oil out of solid material. The screw press works by gradually reducing space. As kernels move forward, pressure increases step by step, preventing sudden shocks that would damage oil quality. Inside, pressure can exceed hundreds of bars. Cell walls collapse, oil separates from solids, and liquid oil escapes through microscopic metal gaps while solids continue forward. This oil is raw and unrefined. It still contains waxes, pigments, and fine solids, but mechanical pressing preserves natural antioxidants by avoiding chemical solvents at this stage. What remains is press cake, a dense solid rich in protein and fiber. Nothing is wasted. This material will later become animal feed or fuel input. Temperature control is critical. Too much heat oxidizes oil. Too little pressure leaves oil trapped inside solids. Engineers continuously adjust parameters to balance yield and quality. Dozens of presses operate together, producing tons of oil every hour. But this oil is still not ready for consumption. It must be purified at the molecular level. Mechanical pressing leaves up to 10-15% of oil trapped in the solid press cake. To maximize efficiency, factories use solvent extraction, a carefully controlled chemical process that safely removes this residual oil. These extraction towers are designed for precise chemistry. Hexane or similar food grade solvents flow through the press cake, dissolving the remaining oil without damaging its nutritional or sensory properties. Solvent penetrates the porous structure of the cake, selectively dissolving